Okay, so the graph of the derivative f prime is a continuous of a continuous function f is shown. So this graph is of f prime. You might want to circle it. You might want to write it again so you can remind yourself what you're actually looking at. Okay? So this A says on what intervals is f increasing and or decreasing, and we have to justify. And at what x values does f have a local max or min, and justify? And on what intervals is f concave up or concave down? Justify. Kind of the same thing that we did yesterday, except we did it from an equation and not a graph. I'm going to give you a moment to discuss this amongst yourselves. See if you can come up with, even if you don't write all that down, the justifications yet, just so we can get the answers down. See if you can figure out what the answers are. Then we'll work on the justifications together. Ready, set, go. What might help you with this? The fun chart. Okay, so without looking at the white paper, see if you can write down the fun chart and see if that can help you. And I'll see if I can write it down correctly this time. Are we ready? And of course, check yourself that you're right, but get it written down. Y'all have done a phenomenal job getting Jason to come out of his shell. I'm just going to tell you that. He used to not talk at all. Everything? Months of progress, trying to stuff him back in there. Are you even talking about math? Where's this silly goose? He's sick. He's excused. Oh, yeah. Yeah, at least write the answers. If you want to write the justifications, that's fine too. But yeah, just write the answers right now so that we don't take forever, because some of us take forever writing things. Actually, go ahead and write the justifications, because it probably makes more sense anyway. I trust you. I think you got this. I don't think you need me anyway. We'll talk through them, though. Okay. I'm going to start them. I'm not writing the actual answers here, so. Yeah, go ahead. Or we can do them one at a time, or you want to do all three at once? Y'all tell me. All three at once. Okay, let's get them done then. What are we confused about? Everything. So you don't have to use any calculus at all. Yeah, that would make it so much easier. If you are watching the video, then pause if you're not done, because I'm going to pause this and when I start back up, I'm going to answer this, but make sure you get it answered on your own first. Okay, so if you have not actually finished this on your own, be good little boys and girls, and pause it until you have. Now, first of all, I just started all these, right? Because that's basically how we have to start our sentences. But I want you to notice the difference in these. So I said F is increasing on and decreasing on. F has a local max at and a local min at, and it's concave up on and concave down on, because the increasing, decreasing, concave up, concave down, they have to be on intervals. It doesn't happen at a point, right? And you're not going to have a local max or min on an interval because it's literally at a point, right? So actually I could have, even without doing any work, it's at x equals something, right? Okay, now I saw some of you decide you wanted a sign chart. Some of you did not. It's preference. I think sometimes it makes it a little easier to wrap your mind around it. It's absolutely not a necessity here, like you wouldn't have to with the equations. I mean, you pretty much have to. So let's just go ahead and do that and talk about the sign chart. So when we did the sign chart up here, we found, well, not there, I guess it was on the page before, never mind. But we found the derivative, found the zeros, and that's what went on our sign chart. So this is our f prime here. And so the zeros for f prime, I get them off my graph. -3, 1, and 4. So if you didn't do a sign chart, you can decide just by the way I'm going to talk about it with this, maybe that would have made it easier for you. Maybe you liked it better the other way. Again, total preference, it's fine. So between -∞ and -3, f prime is negative. Then from -3 to 1, it's positive. Then it's negative again, and then it's positive again, right? Which tells me that f then is decreasing, then increasing, then decreasing, then increasing. Okay? So that I can find that there, instead of having to look at the graph to figure out what's what. But again, it's just a different way to look at it. So I can tell you, and either by looking at the graph or by looking at the sign chart, f is increasing here and here, here and there, sorry, I missed that. So it's increasing on -3 to 1 and 4 to infinity because who? F prime is what? Positive. Okay? Or I can look at the graph and say, all right, f prime is positive here and it's positive here. Get my intervals that way. It's the same thing either way. Then I can say that it's decreasing on -infinity to -3 and 1 to 4 because f prime is what? Negative. Okay. All right. Everybody okay with that? Yes. Greater than 0, less than 0, that's fine too. Less than or greater than 0 is less writing is probably what I really should do. Okay, so now we're looking for f having a local max. Where is the local max? -3, is that the only one? Okay, and 1. What? Relative max is at 1. So I have, these are relative max or mins right here for sure, okay? And when you're changing from negative to positive, that's from decreasing to increasing. If you look at your sign chart, which is again why I kind of think that it helps a little bit, if I'm talking about a max, the max is right here. I can see that with those arrows. So I have a local max at x equals 1 because f prime, what? Changes from positive to negative. Could do that too. Okay. So this right here is a local max, okay, which means these two are local mins. I can look at that and it's because f prime is changing from negative to positive, but that's what these little arrows up here show me, and I can see it right here. I prefer this so I don't get my graph backwards. You know, there's a lot of thinking you have to do. Sometimes thinking is not my friend. All right, so local min at x equals -3 and x equals, make sure you're using the x equals 4 because f prime changes from positive to negative. And I'm purposefully not being consistent with how I'm writing it because I just want to show you what the, oh my gosh. Okay. I should at least be correct if not consistent, right? Ugh. I really do know what I'm doing. From, I know it's, you don't ever believe that, but negative to positive. Just keeping you on your toes. You're doing a great job. I did. I totally did that on purpose. That's almost never true. Okay. Everybody good so far? All right. Now, does my sign chart really show me concave up, concave down? Or does it? The fun chart can help me for sure, right? Concave up, concave down, right? I don't have f double prime, so I'm not even really looking at this row of it, but I would say when you draw it or when you write it out, write out the whole thing every time so you don't forget a part or get confused. But we are concave up when f prime is increasing, right? So f prime is increasing here. And where do I stop increasing over here? Infinity, because that right there is a little point of inflection, right? Okay. So f prime has a point of inflection. That's not just changing the concavity of f prime, not of f. That's why you have to keep your mind wrapped around what am I looking at and what are they asking me for. Okay, so if it's increasing, which it's increasing here and here, that means it's concave up. So this is concave up on, what is it, negative infinity to -1 and 2 to infinity? Huh? Am I doing this wrong? That's right. Make me second guess myself. Okay, look, f is concave up. You agree that this is concave up? When f prime is increasing. This graph is f prime. This is when f prime is increasing, when f prime is increasing, so that's when f is concave up. Not when f prime is concave up. Not doing it visually, we're using our calculus knowledge. That makes sense? Okay. 2 to infinity, and I'm going to run out of room. Because why? F prime is increasing. Okay. F prime increasing. Whoop. Made my fun chart too big. Now, how many intervals are we concave down? Just one, because it is make sure, because you gotta know what it is. F prime is decreasing, so F is concave up on -1 to 2, right? -1 to 2, because F prime is decreasing. What questions do you have? Good? Any questions? All right. So I'm going to make you have to use your noggin here again. We're going to sketch a graph, and we have some information here. We are sketching a graph of f with this information here, these given characteristics, okay? And so I want you to think about what each one of these things mean, and maybe write out to the side what, if this is true about f prime and f double prime, what does that mean for f? Okay, so think about each one of these, see if you can write down something. I mean, this tells you about f, but these four here are all about f prime or f double prime. And if those things are true, what does that tell you for f? Where might we find something that might help us figure all that out? Fun chart, woohoo! It's so fun. You just wrote it right above there. Use your fun chart. See if you can come up with some things that you can think through. You got this. And maybe not all of it is on the fun chart, but some of it is. Think about what it's saying and what that tells you. Are you trying to escape? Yes, so rude. He is escaping. He is escaping. You are escaping in a few weeks, aren't you? We're going to have to throw him a graduation party. Do you have anything written down? Focus. Yay, good job with your dash on your graph. Okay, so let's think about this. The graph of f is what we're trying to graph, right? This first thing right here, f of 0 equals f of 2, which equals 0. What kind of information does that tell me? Where the zeros are, right? So I have a 0, 0, 0. And I have a, what's the other one? 2, 0. If you said 0, 2, I heard it somewhere. Okay, so 1, 2, and then I'm going to plot zeros there. Boom, boom. Okay? Do we agree with that part? We got this, right? Okay, so then it says f prime is greater than 0 if f is less than 1. So if f prime is greater than 0, what's another way to say that? Positive. So this is positive. Okay, and if f prime is positive, what is f doing? Increasing. So this means that f is increasing on x is less than 1, or another way to say it is from negative infinity to 1. I mean, either way is totally fine, but that's what's happening there. Okay, so that tells me something. I don't know that I really want to draw anything in yet, but it's increasing until we get to 1. Okay? F prime of 1 equals 0. What do you think that would help me with? Okay, is there a 0 on your fun chart? No. What happens most of the time when we hit a 0? What did f prime do, like on this graph? Here's a 0. It changed from negative to positive or positive to negative, right? So if that happens, then I either have a relative max or a min, right? Okay, so what I know for sure is a horizontal tangent, okay? Because we could maybe need to know that for some reason, which means relative max or min. All right, everybody good with that? Okay, so then we have f prime of x is less than 0. If, what's another way to say less than 0? Negative. So if f prime is negative, then what's true about f? Decreasing. So that means that f is decreasing when x is greater than 1. Or to think about it from 1 to infinity. Okay, so let's think about this for a second. F is increasing, starting over here, it's increasing, and then it decreases, right? So do you think that this is a relative max or min? Max. I'm going to go with max on that. Okay, we agree with that? All right, then it says f double prime is less than 0. What's another way to say less than 0? Negative. And if f double prime is negative, what is true about f? Concave down. And it says f double prime is negative, like the whole thing, not on a specific interval. So that means that f is concave down always. Okay, so let's think about what this looks like, because we got to graph something, right? It's always concave down. It starts off increasing and then decreasing, and we have a max here at 1, so I can go ahead and put my max in there. It's at 1. I don't know where the max is, but that's okay. Right. And I have my zeros. We've taken care of all of that. So what is this going to look like? A quadratic. I just increase, I hit that, and then I decrease. Now, do I know for sure that that's what's happening? Yeah, kind of. I mean, I think we have enough information for that. We could have some other, but really I couldn't have any other squiggles, because if I have any other squiggles, then that gives me a point of inflection, which changes my concavity, right? So that's pretty much it. Okay. What questions you got? We good? All right. You understand how to think through that then? Because you could be asked to do this, or maybe you're just asked for these kinds of answers. Make sure you can connect all that stuff together. All righty. Graph of the function f is shown in the figure. So if they give me a graph of f, chances are pretty good the question is not going to be about f. All right? For which of the following values of x is f prime positive and increasing? Okay. So when is f prime positive and increasing? See if you can think about that for a little bit. If f prime is positive, what's true about f? Okay, yeah, if f, I'm not going to rewrite this. So if f prime is positive, f is increasing, right? So increasing. So let's highlight everywhere it's in, that's right, everywhere it's increasing here and it's increasing there. You agree with that? I went a little wide on that one, but you get it. Okay, so then if f prime is increasing, what is true about f? If f prime is increasing, what is true about f? Concave up, okay? Concave up. So then let's highlight where we are concave up, and we're concave up here, and there's only one place where they overlap right here, so what's my answer? E. Okay. What questions do you have? Okay, so grab that little white sheet. Okay. What does this picture remind you of? Looks like a little bird to me. I don't know why, like a bird on a branch. Okay. All right. So this is kind of a cool little, it's not just like a decoration at the top. There are 3 x-axes, actually. So it's like 3 different graphs put together, but it kind of makes a little bird. So the dark line, you only have one vertical dark line, and that's your y-axis, but then you see how you have 3 x-axes? Hopefully it, oh, that's right, I printed these off. We didn't copy them, so you can see it. I even gave you the colored ones. So these 3 functions go together, meaning that, so if you notice, here's f is concave down from here to here, and f prime is decreasing from here to here. And f double prime is negative from here to here. That's basically your fun chart in a little bird picture, okay? The f is decreasing from, let's see, we're decreasing from here to here. And if f is decreasing, f prime is negative, which goes from here to here. Okay, so it's just kind of it all relates together. You can really just kind of put your fun chart in there. So depending on how your brain works, if the fun chart isn't doing it for you, draw yourself a bird. I don't know, like if you're more of a whatever works, but it's not just a bird picture. It's a kind of an interesting little thing. All right, so what this is this is just kind of an outline of how do you find these things. So how do we find critical values? And it tells you the critical values are the x values where f prime is equal to 0 or does not exist. We did that a few times, right? Absolute max or absolute min. So when we've been finding these with our critical values, and then remember we've been writing today relative max or min, you can't say that it is absolute unless you do the candidates test, okay? Or another test, which we'll eventually talk about. But then we find the critical values, substitute the values in, and the endpoints, and then the largest one. Okay, so we did the candidates test the other day. And f is increasing or decreasing, and this basically, you can just get this off of your fun chart. Relative max, relative min, that's the first derivative test, right? And then we have the second derivative test, which we'll talk about tomorrow. I know. And then f is concave up or concave down. So this is just kind of an inflection point. So this is kind of all the stuff we've talked about except the second derivative test, but it kind of gives you a little outline of how you find everything, and then a little copy of Fun Chart 2.0. Even though you don't know what 1.0 is, that's fine, but we do that in pre-cal now. Okay, you good on that? So what page did this go on? This was on 54. Okay, so we'll put this one on 55 then. All right, we good? And then you have an assignment that you want to work on. All right, get those put in your ISN. Say bye to Mr. Ackerman's class. Say bye to Daniel the silly goose. Yeah, oh, loser.